This video is for section 14-3 about depressed equations. If you know one root of a polynomial equation, you can sometimes determine the other roots. Let's do an example to see that. Find all of the zeros, meaning find all of the roots of the function p of x is equal to this four-term polynomial. It's a good idea to know what the possible answers are so that you're not trying numbers that aren't even possible. To do that, let's use the possible rational roots test that we used in section 7-2. This is where you take all of the factors of the constant term and divide by all of the factors of the leading term. This will generate a list of possible rational roots that divide evenly into the polynomial. So the constant term is -2. What are all the numbers, including both positive and negative numbers, that are factors of -2? They would be positive or -1 and positive or -2. Now, this number here is our leading coefficient. What are all of the factors, including both positive and negative, that divide evenly into 2? Again, that's positive or -1 and positive or -2. Now let's create all possible numbers from this ratio. We could have 1 over 1, which makes 1. We could have 1 over -1, which makes -1. Or we could put the positive or -1 all over the 2. Making 1/2 or making -1/2. Now, if we switch over and use the 2 in the numerator, we could put that over 1, or we could put the 2 over the 2. That would create 2 or -2. 2 over 2 just makes 1, which we've already listed. So these 6 numbers are the possible rational roots. Now, let's use the factor theorem and synthetic substitution to actually identify a root. Write down the coefficients of the original polynomial. 2, 1, -4, -2. I'm getting those numbers from up here. 2, 1, -4, -2. Make a synthetic division bracket. And choose one of the possible answers and write it over on the left side. The very first one that I even wrote down was a 1, so I'm going to write a 1 there and divide that in using synthetic division. So let's run through the process. Pull down the 2, then multiply. 2 times 1 makes 2, and add these, which makes 3. Then multiply, which makes 3, add, which is -1, multiply, -1, and add these together, -3. The remainder did not turn out to be 0. Therefore, 1 is not a root of the original equation. So in our list of possibilities, we can cross off the 1. We found out it didn't work. Now take your eraser and erase that, and let's try a different number using synthetic division. The next number that I even listed down as a possibility was -1. Let's divide that in there and see what happens. Pull down the 2, then multiply, add these, multiply, add these, and multiply. Add these, and the answer is 1. We did not get a 0 for the remainder, so -1 is not a 0 of the function. We can cross -1 off our list. It was a possibility, but when we actually tried it, it didn't work. Take your eraser, and we're going to try something else. The next number in my list of possibilities is 1/2. So I'm going to write that over on the side. Bring down the 2. 2 times 1/2 makes 1. 1 plus 1 is 2. 2 times 1/2 makes 1. -4 plus 1 is 3. And 3 times 1/2 is 1.5. When you add these together, it's -1/2. It did not turn out to be 0, so 1/2 doesn't work. I'm going to cross it off. It was a possibility, but when I actually tried it, it did not work. Now take your eraser, and we're going to try something else. Let's try the negative 1/2. Bring down the 2. 2 times negative 1/2 is negative 1. 1 and minus 1 is 0. This makes 0. Negative 4 plus 0 is negative 4, and negative 4 times negative 1/2 is positive 2. When you add these together, the result is 0. The remainder is 0, therefore negative 1/2 is a root. So over here on the side, I'm going to write down the roots as I find them. One of them is negative 1/2. Now that we have found one root, let's go on to step 3. Write the polynomial equation in factored form. So what we know so far is that it factors as x plus 1/2 times 2x squared minus 4. And we're asked to write an equation so it's equal to 0. Now, where did this come from? The x plus 1/2 comes from our identification of the root being negative 1/2. We know that whenever we find a root, we can write that as x minus our root. But subtracting a negative number is equivalent to having a plus sign. The other thing we know is that these numbers that we get when doing synthetic division all have meaning. This last number is the remainder, this is the constant, this is the coefficient of x, and this is the coefficient of x squared. So from these three numbers, we can write 2x squared minus 4. Now we can solve the depressed equation. What that refers to is creating an equation from this part of the factored form. From this beginning part, we already know the root was negative 1/2. But from this part right here, we could solve for the roots. So you write 2x squared minus 4 equals 0, and then solve that using any of the techniques you know about from earlier this year. One way to do this is to add the 4 to the other side. Then divide by the 2. Then to get x alone, take the positive and negative square root. And we discovered 2 more roots. So up here on the top corner of the screen, I was starting to write the roots out. We already found negative 1/2 using synthetic division, and now we found the square root of 2 and negative square root of 2 using traditional methods. So here are the 3 roots for our cubic equation. Here's the definition of a depressed equation. When a polynomial has been written in this factored format, this very first linear binomial gives us a root. In fact, we maybe created that because we already knew the root to begin with. This piece right here can be used to create a depressed equation. An equation that comes from an original equation, but its degree is 1 less than the original equation. Let's try another example. Let's solve this equation. Until today, we have never solved an equation that went to the 4th power, that had so many terms. I mean, we did solve an equation to the 4th power when there was only a constant term, right? Because we could get rid of the 4th power by taking what's called a 4th root. But we never solved equations to the 4th power that had all these extra terms in it. So to do this, let's start by using synthetic division to try to find a root. Write out the coefficients, 2, 7, 4, -7, -6, and make the bracket. Now let's try a number. But what are the possibilities? We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1 and plus or minus 2. I'm getting this list of possibilities by looking at the constant and looking at the leading coefficient. Now within this list, it generates a lot of possibilities. One of them is a 1. Let's try that, divide it in, and see if we get a remainder of 0. So bring down the 2, then multiply, add, multiply, add, multiply, add, multiply, and add. Wow, on our very first guess, we did get a remainder of 0. So one of our solutions is going to be a 1. What are the other ones? Because if it goes to the 4th power, we're expecting 4 solutions. Let's use synthetic division again to try to find a solution of this depressed polynomial. What number do you want to divide in? Should we try 1 again and see what happens? I'm not going to, because I notice that all of these numbers are positive. So if I put a 1 right here and I start running through our process and I keep adding things, it's just going to keep getting larger and larger. I'm going to try -1, just see what happens. So pull down the 2 and then multiply. Add these and multiply. Add these, multiply, and add these. Hey, and again, we get a 0, so we lucked out. Our guess of -1 actually divides in there evenly. So right here where I'm writing the roots out, I found another one, -1. I think there might be 2 more to go. At this point, we could do synthetic division again. Or we can rewrite this into a normal polynomial format. This will make 2x squared plus 7x plus 6. And that's equal to 0 if we want to try to solve it. Now, let's solve this by other methods that we know. For instance, maybe it factors, or maybe we would use the quadratic formula. I'm going to try to factor it as 2x times x, and then to make 6, I'm going to go plus 3 and plus 2. The outer product is 4x, and the inner is 3x, and that adds up to 7x. So it does factor. Solving the first factor, we get x is equal to -3/2. In solving right here, we get x is equal to -2. So where we were writing down our list of answers, we have found that -3/2 works and -2 works. Notice that those are in our list of possibilities. So we could have kept using synthetic division, and eventually we would have discovered those answers. Here's the answer to the question. We have solved the equation and found out 4 different possible answers for x. The technique was to start with synthetic division until we got it small enough that we could write it as a quadratic equation. Once we have it as a quadratic, then we can solve it with methods we already know from earlier this year.